Hello everyone, I welcome you all to the first video in the Spring Framework lecture series. In this series, you will learn Spring Framework and developing Java Enterprise applications using Spring Framework. By far, Spring is the most popular Java framework available today. The usage of Spring Framework is not limited to web development. Instead, Spring Framework can be used to develop standalone Java applications as well. Spring is a big topic and it will be divided into multiple videos. In this video, you will learn number 1. Evolution of web application development using Java, particularly the JavaBeans and Enterprise JavaBeans specifications with an example. Number 2. At the end, we will see why there is a need for Spring. So without wasting any time, let us get started. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. Before we start on Spring Framework, it is important to list down prerequisites for this course. Number 1. Knowledge of core Java programming language. Number 2. For database querying, basic knowledge of SQL is required. Number 3. Basic knowledge of any Java build tool like Maven or Gradle to build application source code into runnable artifact. Before we learn about Spring Framework in detail, we have to understand why Spring, what problems is it solving. Let me walk you through the Java development landscape before the Spring Framework. Along the journey, we will understand what problems developers were facing during that time and the need for Spring Framework. Let us jump back in time to the late 1990s. Java was a fairly new language at that time and its popularity was growing day by day. For the first time, Java made it possible to write complex applications made up of independent components. In late 1996, Sun Microsystems released the initial JavaBeans specification. Now, a natural question is, what are JavaBeans? Let me explain the concept of JavaBeans with the help of an example. To recall, we all understand classes encapsulates part of the functionality of an application. JavaBeans are nothing but standalone Java classes which follow a standard set of rules. Technically, JavaBeans is a specification, that is to say, a set of rules or standards, and beans are reusable components or classes. One would wonder why they follow a standard set of rules. This is because to standardize them across the industry, otherwise every developer would have their own definition of beans. Standardization is necessary to have automated tooling available for all. To visualize the concept of reusable components, consider this example. The communicator class shown here has a very simple responsibility of communicating with the user over various channels. Now, if you have noticed, a communicator is expected to communicate with the user, but there is no user representation in the class. By slightly modifying the class definition, we can fix this problem. Now, each method in the communicator class is expected to have a user object. The user class is also highlighted to mark a very important point. The point is, the communicator and user classes now become what we know as reusable components. A driver program can make use of these components anywhere in the application to, number 1, represent a user, number 2, effectively communicate with that user over various channels. For a class to adhere to JavaBeans specification, they must follow some rules. Those rules are, number 1, class must have a public no argument constructor. Number 2, classes must be serializable, that is, class must implement the serializable interface. Number 3, class properties are private and only accessible via getters and setters. Modifying the previous example a little bit, now these two classes completely follow the JavaBeans specification and are officially known as beans in terms of JavaBeans specification. Not sure if you have noticed, the only difference being these classes now implement the serializable interface. Problems with JavaBeans. JavaBeans were released in 1996 and they had their own set of problems. The solution to those problems led to the release of Enterprise JavaBeans Specification. The problem with JavaBeans is that they were too simple for complex application development. Any real-world application often requires features like transactional support, security management, and distributed computing. These features were missing in the JavaBeans specification. To complement JavaBeans with additional features, Sun Microsystems in 1998 came up with another set of specifications, Enterprise JavaBeans, which were part of a larger bundle which later became known as Java 2 Platform Enterprise Edition, or J2EE for short. Enterprise JavaBeans are managed by a central component defined in the specification as the EJB container. EJB containers provide the runtime environment for Enterprise JavaBeans to execute. It is the responsibility of the EJB container to provide transactional support, security management, and other services that are generally required as a part of manageable server platform. Fun fact. Let's have a look at a fun fact related to Java name. In October 2017, when Oracle submitted Java EE to Eclipse Foundation, they couldn't agree on the transfer of Java trademark, and hence it was renamed to Jakarta EE. Jakarta is the largest city of Java Island and is the capital of Indonesia. EJBs are not perfect and they have their own challenges. Let us understand them with the help of an example of EJB developer Jack. Jack works very hard to implement an enterprise Java bean with all the business logic, and now he needs to test it. Since enterprise Java beans run in an EJB container, he needs to start the container, run tests, check for failures, stop the container, fix code, and start the container again. This cycle would continue. He has to spend a lot of time waiting for the container to start or stop. See, enterprise Java beans were not complex just for the sake of complexity. They were complex because they were solving complex problems like remote transactions, distributed computing, etc. But most of the applications don't need these functionalities. On the other hand, during the early 2000s, new programming techniques like inversion of control and aspect-oriented programming were giving Java beans much of the power of enterprise Java beans, but without all of their complexities. Let's have a look at why Spring. EJBs were released in 1998, and back then there were not many alternates available to EJBs. EJBs were not perfect and they had their own challenges, which has led to the release of Spring Framework in 2004. Being the first mover in the direction, it quickly captured the market and now is the market leader in terms of Java EE frameworks. Spring thrives to deliver the same services as EJBs while simplifying the programming model. One of the core beliefs of Spring Framework is that complexity of the application is proportional to the complexity of the problem being solved. A Spring application consists of simple Java Bean classes managed by Spring. Beans are dependency injected into other beans to form a cohesive application. Let us understand in detail what benefits Spring is offering in comparison to Enterprise Java Beans. Spring supports more than 80% of the feature set EJB has without much of their complexities. By complementing standard Java Bean classes with dependency injection and aspect-oriented programming support, Spring makes it super easy to build large modularized enterprise Java web applications. Spring also comes with out-of-the-box modules like Spring Security and Spring Data to easily manage security and persistence aspects of an application. The popularity of Spring is fueled by Spring community beliefs. Those beliefs are: number one, good design is more important than good technology. To explain it more, if an application does not require distribution or declarative transaction support, it is unlikely that EJB is the best technology candidate, but we still choose EJB. The idea behind Spring is we can keep the code as simple or as complex as application demands. The complexity of the application is tied to the complexity of the problem being solved. Number two, Java Beans loosely coupled through interfaces is a good model. To explain it, If we rely on EJB, our service components are tied to EJB specification. For instance, JNDI lookup and EJB home interface. This is a tight coupling to EJB technology. With Spring, Bean depends on other collaborative beans through interfaces, and the Spring container is responsible for resolving the dependencies. There is no complex JNDI lookup or EJB home interface definition. Since there are no technology-specific dependencies, Spring makes it possible to write very decoupled, testable, and easy to maintain code. Number 3. Code should be easy to test. To explain it more, Spring Beans collaborate through interfaces. Nowhere there is a tight coupling to implementation classes, which makes it possible to easily swap out implementations with mocks during testing. Since Spring will only be testing Pojo classes, we don't need a dedicated Java EE container to test Spring Beans. These three core beliefs, coupled with the dependency injection and aspect-oriented programming support in simple Bean Pojo classes, is what makes Spring so powerful. This is fueled by the very active Spring community. That's it for today's video. Comment your doubts in the comment section and I will address them as promptly as possible. In the next video, we will learn two important concepts which govern the Spring framework. Number 1, what is dependency injection and inversion of control? Number 2, how dependencies are internally represented as dependency graph. Once again, thank you and keep learning. I will see you in the next one.